Alrighty, welcome back, boys and girls. It's your main math man, Miss Shane, coming to you live from Summit Academy. In this video, we're going to be working on those first couple pages for the Unit 1 competency test. And that first problem says this. It says, study the function. You have f of x equals x minus 7 all squared. We have a couple different parts, but we're saying to evaluate each of the following. So anytime it has evaluate, it means to get an actual number for your answer. So if you need to write that, we're saying answer equals value. Alright. So as part A, part B, part C, all kind of the same, and we'll do it, step by step. And then part D, it says what is / are the possible values of x for which f of x equals 324. Alright, so in part A, for part A, I have to plug in x equals 4. So I'm going to rewrite it like this. I have f of 4 equals, anywhere where I have an x, I now have a 4. So I have 4 minus 7 squared. And then all I have to do is just evaluate simply. I do 4 minus 7 is negative 3. Again, be mindful of where those parentheses are at. And then I have negative 3 squared is going to be positive 9. So I say my function at the point x equals 4 is going to be 9. For part B, I'll do underneath. It has f of negative 7, so I have f of negative 7. Let me actually change the color. There we go. So f of negative 7, I can rewrite and say I have negative 7 minus 7, and then squared. So this is going to be negative 14 squared, which is going to be, so f of negative 7 is going to be equal to, again, use that wonderful graphic calculator for yourself. I can say, let me move this over a little bit. There we go. So I have, in parentheses, I have negative 14, end parentheses, and then squared. Hit enter, get your answer. So now I can say I have positive 196. All right. And then same setup for part, let's say part C. Plug in that value. And so it has, let me box it in like that, there we go. I have f of 7, again, rewrite your function. Instead of x, we now have 7, so I have 7 minus 7 squared, and then f of 7, let's rewrite that one a little bit better. F of 7 equals 0 squared, which is just 0. Alright. So again, real simple, plug in those values, get your answer. In part D, similar setup, however, instead of now plugging in for x, we can plug in for our y value. So it's saying, hey, we're setting up our left side equal to 324. So in part D, rewrite your equation, so or my function. So x minus 7 squared equals 324. And now the reason why we're doing this is we're trying to find what values of x. So we should get x equals value, where we were saying in our first three parts we get y equals a value. Excuse me. So now we can do inverse operations, and we're solving for x, take the square root of both sides. Please be careful when you take that square root, you end up getting that plus or minus symbol like this. So I'm going to say, let me have like this. I have x minus 7 equals, and I have plus or minus, and then let's take the square root. So again, on my wonderful graph calculator, I do second x squared to get my square root, and then I'm saying 324, hit enter, and says 18, but make sure on your page you can say I have positive or negative 18. This will help create, those possible two values. So that's when it has an S like that, we could say could be more than 1. So I'm saying, okay, I have two possible answers, so let me break this apart. So I have x minus 7 equals positive 18, and I have x minus 7 equals negative 18. So I have to have both of those cases because I should get those two different answers. So now I can use my inverse operations to solve for x. And so I'm saying add 7 to both sides. Again, it works for either equation. Notice how you're getting different values. So on my left answer, I get x equals 25. And on my right answer, I get x equals negative 11. So did we answer the question? It says, what are the values of x? So when x equals negative 11 and when x equals 25, our function equals 324. And you can always, graph your equation, type it into y equals, and get your picture of your function, and you can check these values. But as long as you're able to evaluate, meaning get an answer, you'll be good. Moving on to number 2, same kind of setup. So I have the function x squared minus 7x minus 7x minus 44. So I'm going to say evaluate when f of x, meaning when x equals 0, what is our answer? Well, that's just this is our y intercept. So whenever x equals 0, we have our y-intercept. So I'm saying f of 0 equals 0 squared minus 7 times 0 minus 44. Again, these cancel out, and so we're just left up with f of 0 equals negative 44. So it still works the same way where you're plugging in a value and getting an output for your function, but just be careful when you're plugging in them. You use those parentheses to set it up. For part B, make sure you're setting it up. So I can say, all right, I have x squared minus 7x minus 44. When does that equal 0? So I have a couple ways to do this. So I can do it using my products and sums. So I'm saying, let me highlight it like this. I have my product. My product is going to be negative 44. So I need two numbers that multiply together to get 44. And then I can say their sum is going to be negative 7. So let me write that down. So their sum is negative 7. Their product is negative 44. So I have a couple numbers that I can multiply together. It has to be set up like this. I know I have to have parentheses equals 0. And I can say, all right, I have x in both of them since I have x squared. Since my product is negative, that means I have different signs. So I have one is going to be plus, one is going to be minus. Don't need to have it that large. There we go. So I need two numbers that multiply together to give you 44. I can say I have, this is going to be 4 and 11. And now I can help using my sum, I can say, hey, the larger number is going to be negative, so that means I have to have negative 11, I have to have negative 11 and positive 4. This will help me because now I can say, hey, my two answers, I can say x is going to be equal to the opposite of positive 4 is negative 4, and the opposite of negative 11 is positive 11. So when we have, or when we plug in, let me actually write that separately. So we have this, and x equals positive 11. So those are your 2 points. Those are your 2 points on your graph. When you plug in these two x values, your y value equals 0. And I can actually show that like this. And I'll show it on the graph in here in the calculator in just a second. But for our part C, it says, what do your solutions in part B tell you about the graph of f of x? So we can say something like this: when or at the points, let's say negative 4, 0, and 11, 0, our function hits the, let's say, the x-axis. And what does that mean? Well, that's talking about our x-intercepts. So when y equals 0, which is what we had in part B, our graph of our line hits the x-axis. And what you can do, you can type it in like this: I hit y equals, I hit my function, so I type in x squared minus 7x, and then I have minus 44. I can hit graph to kind of look at that picture, and it should have like a parabola looking picture to it. There you go. If you need to zoom out, it kind of looks like that. But I might also able to say, okay, if I have my function, I should be able to check and see. So if I go, if I say, so let me do zoom, and then let me zoom. If you hit zoom and then 0 to zoom fit, kind of gets in there too, or you can hit zoom and then do zoom out. So zoom 3, hit enter, and we'll zoom out a little bit so that way you can see the full picture. So I can say, okay, if I hit second calc, I can find a 0, meaning when is your graph of your line hitting the y-axis. So I know I can put my left bound, to the far left where it hits the x-axis, hit enter, scroll to the right a little bit, hit enter, and I know it's going to be between those 2 points. I can make a guess. And it will give you a 0, meaning my left point, when my x value is negative 4, my y value is 0. Do the second calc and then 2 to get 0. Do the same thing on the right side. I can trace using my arrow keys. Put your left bound below the x-axis. Put your right bound above the x-axis. If I do it like that, back up again. And then put your guess in the middle of those two, hit enter, and it will give you a 0. So when x equals 0, again, this is exactly what we proved in our statement. We're saying at those 2 points, our function hits the x-axis. Okay, so let me clear that out for us. Move on to the next one. All right, so in number 3 it says if f of x equals x squared minus x, then evaluate. That says f of a minus 7. So same kind of setup before. Instead of an x value, we're writing it like this. And so we have some options here, but I'll show you how to do it. So again, anytime whatever is inside of those parentheses, so I'm taking this entire amount. If I can go to this one, there we go, sorry about that. If I have this entire amount, I'm plugging it inside into my x values. So I rewrite it like this. I'm saying I have f of a minus 7 is equal to, and I have a minus 7 squared minus a minus 7. So wherever I have an x, I now have a minus 7. So just rewrite it like that. Then we can say we have, and we can evaluate our function. Anytime I have on the side here, I'm going to write an example. If I have x minus y squared, please be careful when you're squaring each of those values. Another way you can write it is like this. I can say, okay, I have the first term squared, so I have x squared. I have two times the product of these two, so minus 2xy, and then I have the third term squared, so plus y squared. So it's always going to be like that form. Again, if you need to have it like that, that's what I'm going to do. So I'm going to have, okay, first term squared, so I have a squared. I have 2 times the product, so I do I do a times negative 7 times 2 is going to be negative 14 times a, and I have this second term squared, so plus 49. So that's this part here. Second part, so now I can say I have a minus, and I can say I have minus a plus 7. Again, be sure to be careful. I multiplied each of those terms inside the parentheses by -1 since my coefficient is -1. So it looks something like this. Let me make this smaller. Alright. So now I can say, okay, combine like terms. I have a squared is going to be my only a squared. I have now negative 15a, since I can combine these two together. And I combine my constants together. I'm going to say plus 56. So when this is equal to f of a minus 7. So when x equals a minus 7, our output is going to be a squared minus 15a plus 56. And be sure to ask questions on that one if you need them. Moving on to number 4, study the function x squared plus 4x minus 5, and we have a couple parts for this. Again, this is just like the practice we did. What I want you to do first, it gives you that function, so I'm going to plot it in. So I have x squared plus 4x, and then minus 5. Again, be careful with those negative values. So again, this is your minus symbol, this is your negative symbol, so make sure you're very careful between those two. So now I can say I hit graph. Let me actually do zoom 6 to get the standard graph, and it should look something like this. And if you need to, you can kind of trace it using your calculator like this. So what are our steps? Well, I can have our, let me write it like this. So I have x intercepts. Use that graphing calculator to your benefit. So I have x-intercepts at So where does it hit? Well, I can hit second trace. I'm going to say, okay, where does my function equal 0? Put a left bound. I'm saying put a left bound there, put a right bound there, and I can say, okay, guess in between those two, and I have a 0 at -5. So I have 1, 0, so when x equals -5, and I can do the same thing, second trace, hit 0, give me my left bound, give me my right bound. Again, it's like I'm framing that picture. I'm saying, hey, it hits the line right there, but in between those 2 points, I have my guess, and I have a 0 at x equals, so let's have and x equals +1. So what does that mean? Well, it means that I have a point like this. So I have a point at -5, my graph hits the line at x equals -5, and x equals +1. This is helpful because it kind of helps me build my graph. And so now let's do something like this. We can say, what do we have next? We have a y-intercept. So I hit second trace again. I'm looking for a value, so when x equals 0, I have my y-intercept. So I hit second trace value, I plug in x equals 0. What's my output? Well, that means that I have, so let me separate it like this. I have y-intercept. Where does it hit the y-axis? At y equals -5. So that means I can plot the point at y equals -5. All right. Underneath of that, we can have what's going to be our min. So let's do, as you're kind of looking at your graph, notice how it's a parabola facing up. So that means I can hit second trace. I can hit my min, so I'm going to hit 3. Again, to kind of frame in, I know it's going to be towards this bottom point, and so I can frame it in. I can say, hey, my left bound, my right bound, and I can make a guess in between those two. And it's saying it has a minimum at that point. So if I write it like that, I could say I have a min. A min is going to be an ordered pair, so it's going to be the ordered pair -2 and -9. So I can plot that point, -2, -9. All right. So again, make sure you're kind of graphing those points for yourself. That way you can have that sketch of your function. I should be able to have a point on -4. Again, I can check it as well. I can do a second trace and hit value when, or second trace. There we go. Second trace value, and I'm thinking I have a point at -3. So when x equals -3, my output is -8. So this helps build my function. And when x equals -4, what about x equals -4? I end up with that y value of -5. Okay. So now that I have some points, I can kind of sketch my line. If it will stop drawing everything, there it is. So now I can say, okay, sketch my line of my function. So something like this. Again, it doesn't have to be perfect, as long as you're tracing along, making that curved line, going through those points, it'll be good. Okay. Not perfect, but that's okay. So what does that mean? Well, we have a min at that point, we have a max is going to be positive infinity because it just goes up. We can say our axis of symmetry, what is our x value at the minimum? So axis of symmetry is going to be at x equals -2. That's just saying if I look at this vertical line, I know that it is a reflection over that line. For the vertical stretch and shrink, it's talking about our leading coefficient. So if we look at our leading coefficient, we can say a equals 1. So there is no stretch. There's no stretch or shrink since a equals 1. So as long as you mention that, you'll be good. And then lastly, domain and range. Again, have some ideas with that. So for domain D, I can say it's going to be all real numbers. And I can say for range, what is going to be my min? If I look at my min needs to be fixed. So my min, it'd be great if it didn't do that. There we go. My min is going to be at -9. So I say any y values greater than or equal to -9 for my range. So any y values greater than that will be good. So again, make sure you have each of those parts. I'm saying x-intercepts, y-intercepts, min, max. Axis of symmetry, is there a vertical stretch or shrink? What's my domain? What's my range? And sketch the line. So again, make sure you're using that graphic calculator to get those values. Be sure to ask questions, check with me with office hours, and as always, super slam that subscribe button.